Hi, this is Blessed Elvis, and welcome to today's lesson. So this is part 5 of the polynomial functions. However, in today's video, we are going to discuss the identical polynomials. So let's see how we can use the identical polynomials to solve the given values of the variables. So let's do that using examples. So let's say you have 3x raised to power 3, and then you also have negative 8x squared, and then you also have positive 4x, and then you also have negative 5. Let's say this equals to x, open brackets, ax, then plus b. Okay, and then this is multiplied by, let's say, x minus 2. And then let's say this is added to constant value c. So how can we find the values of a and c? The only thing that we need to do here is expanding this part here. When we expand this part here, then we come to compare with the values that are here. So let's do that. So our main focus here will be on the right side for now. So let's expand this side. So here we have x multiplied by ax. We are going to have ax squared because x multiplied by x, it's x squared. So we are going to have ax squared plus then x multiplied by b. We are going to have bx. Okay, so let's put this in brackets. So here we have x also minus 2 and then added to constant c. So in this case here, let's also expand this given function here. Let's simplify it. So ax squared multiplied by x, we are going to have ax raised to power 3 because x multiplied by x is x power 3. So we are going to have x power 3, and then the same ax squared multiplied by negative 2, we are going to have negative 2 ax squared. So we are done with this side here. So let's go to the other side, which is bx. So in this case, bx multiplied by x, we're going to have bx squared because x multiplied by x, it's x squared. So it's going to be positive bx squared. And then negative multiplied by positive, we are going to have negative. Then bx multiplied by 2, we are going to have 2bx. Then added to constant value, which is c. Okay, rather c. Okay, so in this case then, let's now simplify this given expression here. So we are going to categorize them according to the values of the powers of x. Okay, so if you can see, the value which has this one, x power 3, it's only a, or rather it's only this first term here. So in this case, this is not going to be compared to any other, or rather added or subtracted to any other. Hence, it's going to be written separately. So we are going to have a x raised to power 3. Then this one and this one both have x squared. So in this case, this implies that this one and this one can be factorized, where we simply replace, or rather factorize x squared since it's common to both sides. So in this case then, in the brackets, we are going to remain with negative 2a. Let me just write this properly. Negative 2a, and then plus, we are going to remain here with just b. Okay, and then here we have x squared since we have factorized it out, and then here the only value which has x is 2b. So this is just going to be 2b, rather 2b x, and then plus constant c. So we have that. By the way, if you want, this x squared can be in front here. It's okay. I've just factorized it out because I want to have this one in the brackets there. Now, remember, to the first place here, we have 3x raised to power 3, negative 8 squared, positive 4x, and minus 5. So, if we compare this one to what we already have here, we can see that the only value which has x raised to power 3 is this one here, which is 3x power 3. And we have this one here, which has a. So on the a part, we have what has x power 3, and on this side here, likewise, we have 3, which has x power 3. So if we compare this, so you have to pair them in terms of the same values of x. So since this one has x power 3 and this one has x power 3, we are going to compare them. Since this one here has x power 2 and this one here has x power 2, we are going to pair them. Since 4x has x and negative 2b has x, we are going to pair them. Since c here is constant and the negative 5 here is constant, we are going to pair them. That's how we pair these guys here. So let me just wrap this part here, the top part here, so that we can use it for our comparing of the values. Okay, hopefully that you are following. So in this case then, we are going to get the value which has x power 3. Of course here it's 3. And in this expression, we are going to get the value which has x power 3, which of course is a. So in this case, the value of a is what? Is simply 3. So if you don't want to show that, you can simply say 3x raised to power 3 equals to a x power 3. So since x is common, we can simply divide it to both sides and then cancel it out like this. So in this case then, 3 equals to a. So our value of a is what? Is simply 3. So we have found the value of one variable. Okay, so in this case then, let's also find the value of which one has x power 2. So let's compare them. So here we have negative 8x raised to power 2 equals to, in this one we have negative 2a plus b, and then this has x raised to power 3, or rather 2 here. So since x squared is common to both sides, we can simply cancel it out and then remain with negative 8 equals to negative 2a plus b. But remember, we have already found the value of what? We have already found the value of a. So where there is a in this case, we are going to replace. Okay? So let's do that. So in this case, let me just wrap this part here. Okay, I won't rub these others because we need them. So I'll just rub whichever part is not necessary. So even this top part here, we have already used it. Okay. So in this case, let's now replace where there is a with what? With 3. So we are going to have negative 8 and then equals to negative 2. Where there is a, there is 3 plus b. So let's find the value for b. So in this case then, we can multiply negative 2 multiplied by 3 here. We are going to have negative 8 equals to negative 2 multiplied by 3, it's negative 6. And then here we have b. Okay, so we can take this negative 6 to the left side. So we are going to have negative 8 added to 6 equals to b. So what's negative 8 plus 6? Okay, it's negative 2 equals to b. So our value of b is what? Is negative 2. So we have b being negative 2. So our a is 3 and our b is negative 3. But remember, we also have the value for c, so we should also find the value for c. So let me just rub these values here, since we don't need them anymore. So make sure that you write them somewhere, because we're gonna write them at the right end of this video. So for the sake of space, I will just remove them for now. Okay, so just take note of the values that we have found and then keep them aside. Now we have solved for x squared, so let's go for x. So this one here has the value of b, but we have already found b. Anyway, for the sake of just clarity and practice, I will also write that. So the one that has value of x here is 4x, and the one that has x here it's negative 2b, okay, which of course has x. So since x is common, I will cancel it. So I will cancel it to this side and this side. So we are just going to remain with 4 equals to negative 2b. So let me divide negative 2 to both sides. So here, when we cancel this, we are simply going to remain with b, and then this equals to negative 2 into positive 4. We're going to have negative 2. So as we found earlier, still we are having the value of b as negative 2. So if we had not used this, the value of the x squared, we could have also used this to find the value of b. It still could have given us the answer. So that's how you can compare them. So I've done this for the sake of maybe it might not give the same values, or you might have the simultaneous equation to solve here, and then if you just end it there, you might have problems. So I've done it for the sake of explanation. Okay, but that was not necessary since you have already found the value of b here. So here it's not necessary. If you wanted, since you are looking for the value of b here, you could have just simply used this one. It's okay, either of the two is just fine. So let's jump to the constant value here. So we have the constant value, which is c, and in here the constant value is negative 5. So in this case, this is simply direct. So the value of c is negative 5. So in this case, we have our values. So for a, our value is 3. For b, our value is negative 2. And for c, our value is, okay, our value is simply negative 5. So these are the values of the given identical polynomial. So let's look at one last example. So let's say you have 2x raised to power 3, and then you have negative x squared, and then you have negative 7x, and then you have, let's say, negative 5. So this equals to, let's say you have, okay, let's say you have ax added to b, okay, and then this is, let's say, multiplied by, this is multiplied by x minus 1, and then we have also x plus 2, okay, positive 2, and then this is added to constant value c. So let me just write it down here, okay, for the sake of space. So this is the identical polynomial that we have, and then we have been asked to find the values of a, b, and also c. So what do you think we can do here? So simple, we just have to focus on this side here and then expand this given expression. So let's do that. So let me just focus on this side for now. So this side will just be kept just like that. So in this case then, we are going to have ax multiplied by x. We are going to have ax squared, because x multiplied by x, it's x squared. Then the same ax multiplied by negative 1 here, we're going to have negative ax. Okay, and then we jump to b. So b multiplied by x, we are going to have positive bx, and then b multiplied by negative 1, we are going to have negative b here. Okay, so we are done for this part. Let me just write the remaining part here, that is x plus 2 and then plus constant value c. Okay, so let's simplify this further. So in this case then, let's simplify this multiplied by all of these in here. So in this case then, we're going to multiply ax squared throughout in here, this throughout in here, this throughout in here, this throughout in here, until we have a simplified version of this expression. So you can go ahead and do likewise. So ax squared multiplied by x, we're going to have what? So for the sake of space, let me even begin from the far left side here. So we're going to have ax raised to power 3. Then ax squared multiplied by positive 2, we're going to have positive 2 ax squared. Okay, we are done for a. So let's go for negative ax. So negative ax multiplied by x, we're going to have negative ax raised to power 2. And then negative ax multiplied by 2, it's negative 2ax. Okay, then let's come to b here. So bx multiplied by x here, we are going to have bx squared, okay, squared, bx squared. This is x, so bx squared, and then bx multiplied by 2, we are going to have 2bx. Okay, and then let's come to negative b. So negative b multiplied by x, we're going to have negative bx, and then negative b multiplied by 2, we're going to have negative 2b. Then we have the constant value, which is c. Okay, that is c. Let me just, yeah, we have c there. So this is the simplified expression of the polynomial function we have on the right side. So let's now compare the values. So there is no other value which has ax squared raised to power 3. So this is just going to be the way it is. So we have now to start pairing them. So this one has x squared, and this one has x squared, and this one has x squared. So we have three values which have x squared here. So in this case, we know that 2ax squared can be subtracted, or rather ax squared can be subtracted from 2ax squared, which of course is what? So 2ax squared minus ax squared, it's simply ax squared. Okay, so let me just write them in order. Since here we have px squared, it's going to be here px squared. Okay, so let's go now to the values of x values. So we have this one here, we have this one here. We know that 2bx can subtract negative bx. So negative bx from 2bx, we're going to have positive bx. And remember, we have negative 2ax here. So this is going to be negative 2ax, and then we have positive 2bx minus bx, we're going to have bx. Okay, so we are done with this part here, and then the last part that's remaining is where we have these last constant values. That's negative b plus c. So these are the values that you have. So let's simplify further this one. So here we have x raised to power 3, and then let's factorize x. So we are going to have x squared, rather, we're going to have a plus b, and then x squared outside the brackets, minus, even here, let's factorize x. We're going to have 2a plus b, and then here we remain with x, and then minus 2b plus constant value c. So this is the simplified expression for the identical polynomial function which we had. So let me just rub this one and start pairing the values with what we have on the left side. Okay, so let me just rub this so that we can use the space. So hopefully that you have followed up whatever we are doing. Okay, so now the only value which has x squared in this expression is only a, and the only value which has x raised to power 3 is only 2. Or rather, here I said squared, sorry, I don't know why that is in the mind. The only value which has ax power 3 here, it's this one, and the only value which has x power 3 here, it's this one. So let's pair the two. So we have 2x power 3 equals to a x power 3. So this one and that one cancel, so we're going to have 2 equals to a. So in this case, our value of a is going to be 2. So let's keep this information because we're going to need it as we go further. So our value of a is 2, so keep that in mind. So let me rub it and then find for others as well. Okay, then let's go to the second part. So the second part has x squared. So the second part which has x squared in here, it's this one, and the second part which has x squared here, it's this one. So in this case then, we are going to have what? We're going to have negative x squared equals to a plus b, and then outside the brackets we have x squared. So in this case here, we know this is the same as there is a negative 1 here. So in this case, this and that will cancel, and then we're going to remain with negative 1 equals to, where there is a, we have already found that a is 2, and then we have b here. So in this case then, we can take this 2 to the left side. We're going to have negative 1 minus 2, which of course is going to be that. So in this case, solving this expression here, we are going to have negative 1 subtract negative 2, or rather negative 1 subtract 2, we're going to have negative 3 equals to b. So in this case then, our value of b is going to be negative 3. So this is the value of b that we have. So let's also keep this information here so that we go and find the other values. So let me simply wrap this part here since we are done with it. Okay, so we go to the value which has now x. In this case, the value which has x, it's negative 2a plus b, and then in this case, the value which has x, it's negative 7. So we're going to have negative 7x equals to negative 2a plus b. However, we have already found the value of a and the value of b. So this is not necessary now since we have already found the values of a and b. If we had not found the values of a and b, we could of course consider this. So since we have already found the values, it's okay, we're going to just waste time. So if you have already found the values, if you find that in the expression that we will have after you simplify, you have already found the values, you just have to skip it because it's going to waste your time because you have already found a and b, so it's not necessary going back again. Now let's go to the constant values. So the constant values we have on this side, it's negative 2b plus c, and the constant values we have this side, it's negative 5. So we're going to have negative 5 equals to negative 2b plus c. Now we already have found the value of b, so we just have to replace. So here we have negative 5 equals to negative 2, and then where there is b, we had found that this is negative 3, okay, then plus constant c. So let's find the value of c. So in this case, we're going to have negative 5 equals to negative 3 multiplied by negative 2. We're going to have positive 6, and then plus constant value c. So positive 6, when it comes to the left side, it's going to be negative 5 here, and then this is going to be negative 6 equals to constant value c. Then negative 5 added to negative 6, we're going to have negative 11 equals to constant value c. So in this case, our value of c is negative 11. So this is the value of c that we have found in this expression. So to put this in the final answer, we have therefore found that our a is positive 2, and then our b is, rather this looks like 13. So so our b is negative 3, and our c is what? Is negative 11. So this is how we find the given identical polynomials. You simply expand the given polynomial and then compare the values with the ones that are on the left side. Thanks once again guys for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.